Alright, to solve this equation, we need to clear the denominator. That's one way to do it. So that means get rid of all the fractions. So to do that, we're going to multiply the entire equation by the common denominator. So this is already in factor form, this already is, so both of these couldn't be factored, but this one can be factored. So instead of b squared minus 4, that could be factored and changed to b minus 2 times b plus 2, because it was a difference of 2 squares. So now the common denominator, I'm going to take b minus 2, I'm going to take b plus 2, and it already has a b minus 2 here, it already has a b plus 2. So that's the common denominator, and now I need to distribute this to the entire problem. So what ends up happening here is this b minus 2 is going to cancel out with this b minus 2. It's going to cross cancel. And what's left is this b here and the b plus 2. Then I'm going to bring down the minus sign here. Okay, well this b plus 2 is going to cancel out with this b plus 2, and what's going to be left is the b minus 2 here. And so this is going to be distributed, multiplied to this 5 here. Okay, now here, this b minus 2 is going to cancel out with this b minus 2, and this b plus 2 is going to cancel out with this b plus 2. So there won't be anything left in the to distribute out here, but we're going to have the 8 still left. So we bring down the 8. So now we're going to simplify this. So distribute the b here, and here this is a negative 5 that needs to be distributed. So negative 5b plus 10. Now I'm going to combine the like terms here. The 2 and the negative 5 makes negative 3b. And now what I have left is I have an equation that has an exponent, a polynomial equation. So just like last chapter, we learned that to solve something like this, we have to make it equal 0 if we want to use factoring. So I'm going to go ahead and subtract 8 here and here. Whatever you do to one side, you do to the other. So we're left with b squared minus 3b plus 2 equals 0. So now we need to factor that. So since it's a trinomial, we need to think of what multiplies to 2 but adds to negative 3. So negative 2 times negative 1 is positive 2, and negative 2 plus negative 1 is negative 3. So now we're going to split this up and solve each one separately. So we get b equals 2 and b equals 1. So now before we circle that and say, oh, that's our answer, we need to make sure that it doesn't produce an extraneous answer. So if I take the answer we got of 2 and I get rid of the b and plug in 2, here we're going to get 0 in the denominator. So because one of the fractions will have a 0 in the denominator, this is extraneous. It is not a solution. Now if we do that same thing now with the 1, let's see if that produces a extraneous solution. So we're going to take the 1 and put it where the x's were. And this would get us negative 1, so that's okay. This would get us 3, and this would get us negative 3. So this won't get us an extraneous solution. And then again, if you want to make sure your answer is correct, you would need to get rid of this b, and you would need to plug in a 1 here, and here you would have 1 divided by negative 1, which is negative 1, and here you would have negative 5/3, and here you would have 8 divided by negative 3, which is negative 8/3. And then negative 1 minus 5/3 would also be negative 8/3, because we would change the 1 to 3/3, find a common denominator. So we get the same thing on both sides, so we would know it works.